Hello, this is Satish Reddy. Okay, today we are going to discuss one topic most important for objective, especially for JEE NEET exams here. The topic is isomerism. It is isomerism in complex compounds or coordination compounds. It is. Today we are going to discuss about the important topic in complex compounds. Definitely you will get one objective question from this topic for any competitive exams like the NEET JEE here. The topic is like so isomerism it is. Isomerism in coordination compounds it is. So what is that isomerism in coordination compounds? Let's observe. Two types of isomerisms will exhibit by complexes. What are those? Like geometrical isomerism, another one is optical isomerism here. Again, geometrical isomerism is possible in two types of complexes. That is complex with the coordination number 4. Another one complex with the coordination number 6 it is. Okay, let's come to this discussion then. Okay, by using this simple table here, you can answer the any objective questions in shortcut way here. Let's observe this. Geometrical isomerism with coordination number 4, but the complex should be DsP2 hybridization or sp2 hybridization only. That means the complex must undergo DsP2 or sp2d hybridization only. Then it exhibit which hybridization? Which geometry it is? Square planar geometry it is. So coordination number 4, square planar complexes only shows geometrical isomerism it is. So what type of possibilities are there? Let's observe. Here, two categories I am given to you there. The first category you can observe that not possible condition. So for these complexes here, the geometrical isomerism is not possible. For these complexes here, the geometrical isomerism is possible for us there. So here, Ma4, that means metal with 4 same ligands, not possible. Metal with 3 ligands and 1 different ligand, so not possible. So metal with bidentate ligand with same donor atoms it is. So here also geometrical isomerism not possible here. So let's solve some questions here based on this topic here, geometrical isomerism. So which of the following will show geometrical isomerism here? So which complex shows the geometrical isomerism? Let's observe in this complexes here. See, when we are observing that the first option here, nickel 2 chloride is given, 2 bromido is given. So chlorido ligand and bromido both are weak ligands it is. So when it is weak ligand, definitely the pairing of electrons not takes place here. So it undergoes which hybridization it is then? sp3 hybridization it is. Okay, sp3 hybridization means it has geometry. So tetrahedral geometry. They will not show the geometrical isomerism. So go for second option then here. So in this option you can observe the central metal atom is nickel, cyanido ligand is there, bromido ligands are there. So this cyanido ligand is what it is then? Strong field ligand it is. So what happens? Strong field ligand enhances pairing of electrons. So inner d orbital becomes empty. Then what it is? dsp2 hybridization is possible for this complex here. So which one it is? The dsp2 hybridization is possible. Then it shows what it is, definitely square planar geometry. When it is square planar geometry, so automatically geometrical isomerism is possible in this case. Come to this, all are weak ligands in third option here. Definitely the hybridization is what it is there. sp3 hybridization it is there. Then come to fourth option then here. So here oxalator it is. Okay, so this is oxalator then. Bidentate ligand with the same donor atom say. So bidentate ligand with the same donor. What are the donor atoms in oxalator? Both are oxygens only. With bidentate with the same donor atoms, geometrical isomerism is not possible from the table is given out. So okay. So now observe this isomers here. How to draw the isomers for the second option? Let's observe here then. So nickel it is a square planar shape you can draw here. Okay. So like two cyanides on adjacent position. Now this isomer is what it is there? Cis isomer it is there. Two cyanides on adjacent position. This is cis isomer it is. Then two cyanides on opposite side here. Two cyanides on what it is there? Opposite side you can draw here. That is trans isomer is. Two cyanides on opposite side. Now it is what it is there? A trans isomer it is there. Okay. Cis isomer and trans isomer. So like this, the geometrical isomers will form it. Okay, students, let's come to one more question regarding to the same topic here. Let's observe the question also. So, which of the following complex forms three geometrical isomers here? This is very, very important model. Then let's observe here. Which of the following complex forms three geometrical isomers? Now, observe first option here. So generally there is a confusion between these two options here. Why? Because the coordination number, the complexes having four different ligands generally forms three isomers, three geometrical isomers here. But in this case, observe here, in these two cases you can observe here. So your first option, all are weak ligands only here. So coordination number 4 with all four weak ligands it undergoes sp3 hybridization. It is when it undergoes sp3 hybridization, it has a tetrahedral geometry. It is there. Okay, now come to second option then here. So in this second option here, observe so for platinum, amine ligand acts as a strong here. Okay, so for platinum metals generally, or not only platinum, for 3D, sir, 4D, 5D, 6D, okay, higher metals it is, amine acts as a strong ligand here. So definitely here what happened for platinum, pairing of electrons takes place in this process. So four different ligands are there. So complex which are having four different ligands and showing what it is then geometry, that is DSP2 hybridization with the geometry square planar it is. Okay. These complexes forms three different isomers it is. So most important it is let's up the complexes which are having four different ligands and having DSP2 hybridization with the square planar geometry only forms three different geometrical isomers it is there. So come to the fourth option then here. Both are weak ligands. Okay, it shows what it is then. Geometry it does not show geometrical isomerism. Why? Because it undergoes sp3 hybridization. Now come to fourth option here. Yes, it undergoes what it is then. DSP2 hybridization because cyanide is a strong ligand. So this complex definitely undergoes DSP2 hybridization and having square planar geometry, but it forms only two isomers it is. That is cis isomer and trans isomer, not the three isomers. But the question is they asking for three geometrical isomers. Three geometrical isomers only possible with four different ligands. Coordination number 4 and four different ligands. It is there. Observe the uh, previous related question only. This is also. So how to write the four geometrical isomers for any this complex here after here. Okay, so in this complex you can see the four different ligands are there. Okay, how to draw the three different isomers with four different ligands. Let's observe here. First observe it is amine, chlorine, bromine and H2O ligands are there. So first you can fix the position of one ligand it is. For example, if here I am going to fix the position of H2O ligand it is in all cases. You can observe it. So in all cases it is position of H2O is fixed here. Now with respect to H2O, NH3, both are adjacent positions. So this is cis isomer you can write here. Now come to second one here. H2O here. Okay, at this position, if I am writing NH3 here, again what happened here? H2O and NH3 are adjacent positions only. So this is also a cis isomer only it is. Now come to third one here. Okay, wait, remaining you can write like chlorine, bromine you can write as it is. Now come to another one also here. So in third isomer you can observe that the position of H2O is fixed. In first two cases what you are observing, H2O and NH3 adjacent, so cis. In second case also, H2 and NH3 is adjacent, so it is also cis isomer here. Now come to third one then here. The H2O and NH3 you can write in opposite side here. Okay, and the halogens you can write in opposite side here. So now it is what it is then trans isomer it is. So this is the possible two cis isomers and one trans isomer for four different ligands, coordination number 4 complex acid.